Good morning. So today we're going to move into section 12.3, and it should be pretty similar to what we did yesterday, so that's the good news. Today we're going to be finding the surface area of pyramids and cones. And if you remember yesterday, it was prisms and cylinders. And so obviously if we were together at school, I have a lot of these three-dimensional figures there, but you got to, kind of think about, okay, what is the difference between a prism and a pyramid? Or a cylinder and a cone, okay? So a pyramid, if you look at this picture right below here, is a polyhedron in which the base, so there's one clue, is a polygon and the lateral faces are triangles. So if you go back to yesterday and we had a prism, if we would have had like a rectangular prism, it would have had two rectangles as bases and its lateral faces would have been parallelograms or rectangles. Today, our base is a rectangle and we only have one of them, but the lateral faces are all triangles. So it says, note, a regular pyramid has a regular polygon for its base. That just means that all the sides are congruent. So it could be like a square or a regular pentagon. And then a big thing to this one, something kind of new, is the slant height of a regular pyramid is the height of a lateral face. So in these, we're going to have two things. We're going to have the height. Sometimes I say the height, and we're going to have the slant height. Okay, so really pay attention on this picture. The height is going to go from the very tippy top of your pyramid straight down to the center of that base. So if I'm in class, a lot of times I say, okay, imagine pulling a string, like pulling it tight from the top through the very center of the bottom. Okay, over here on this lateral face, this is going to be your slant height. Just the height of this lateral face is your slant height, and we label that with a cursive L. Okay, we labeled this other one, the height with an H. So that's probably the trickiest part to this, is just making sure you know the difference between your slant height and the actual height and being able to use the appropriate one when needed, okay? So if you remember, the surface area of a regular prism would be 2b plus LA. If it's a regular pyramid, it's going to be 1 big B plus LA. And your base, there's only one of them. Don't forget that your lateral faces are all going to be triangles now. Okay, another formula you may see, we're not really going to use this, but big B plus 1/2 times the perimeter of the base times the slant height. This may appear for you like possibly in the future, but I'm not huge on like memorizing formulas. I'd rather you understand that a pyramid has one base and a bunch of lateral faces and be able to come up with the surface area that way. Okay, so moving here to our first example, it says find the surface area of the regular square pyramid. So it's a square pyramid. So I know that's 1 big B plus lateral area, okay? It's a square, so my base, you can either put like a side squared here, or you can put base times height. And then because it's a square, it has 4 sides. They're all congruent, so it's going to be 4 congruent triangles. So these are triangles. So my square looks like it's a 10 by 10. So this is going to be 10 squared plus 4 times 1/2. Now what's the base of this lateral face right here? Well, it has to be 10 because it's a square. And what's the height of the lateral face? So I'm looking for this height out here of my lateral face, and they have not given that to me, okay? Now, what they have given to me is the height, what I call the height. And if you can kind of see this cutout right here, that is going to form a right triangle, okay? So this is going to be the height of your lateral face, which is also known as a slant height. So in this picture, I know this is 12. I need to find this because that needs to go in right here. And then half of the bottom down here, cut 10 in half, that would be 5. Okay, now to save us some time, you could obviously set up L squared is 5 squared plus 12 squared and solve that, but this is a Pythagorean triple. If you remember, it's a 5, 12, 13. So 13 should go right there. And so we end up with 100 plus, I believe this is all 260. And so this ends up being 360 feet squared. Remember, it is area. It's just the area of a bunch of faces added together. All right, let's try the next one. So by the way, you name these shapes by their base. So in this case, it's like, okay, what is the base? So if you look down here, it's a triangle. So this is a triangular pyramid. So it's going to have a lot of triangles because not only is its base a triangle, all of its lateral faces are also triangles. The one good thing is the base, it looks like it's an equilateral triangle. So that means all three of my lateral faces will be the same. So we have 1/2 base times height for the base triangle, the 4, 4, 4. And then we have 3 more different triangles that have a different 1/2 base times height. So on my base triangle, it looks like the base is 4, the height of that bottom, so this guy right there is 3.5. Then I have 3 of those lateral face triangles going around, so it looks like that base is also 4, but that height out here is 8.1. So we've got 2 times 3.5. That's obviously going to give us 7 right here. Plus we have 3 times half of 4 is 2 times 8.1, which gives me 48.6. Add that to 7 and we get 55.6 meters squared. Okay, moving on to cones. So if you think about a cone, it's going to be the base, obviously, plus the lateral area. Okay, but this gets tricky because you've got the circular part involved. So the other way, like we talked about on the front, it could be 1/2 perimeter times the slant height. Well, perimeter of a circle is circumference, okay, times the slant height. So the area of this base is just pi r squared. And this back half becomes pi RL, because this would be, the circumference of a circle is 2 pi r, so 1/2 of 2 pi r would just be pi r. But this right here is what I want you to memorize for a cone, okay? So remember yesterday, a cylinder was 2 pi r squared plus 2 pi rh. Cone is pi r squared plus pi rl. So this one is a cone. It's got a circular base. I'm going to write my formula, pi r squared plus pi rl. Looks like my radius on this one is 10. And it looks like they did not give me my slant height. So remember, my slant height is out here. Okay, so again, you're going to do L squared is equal to 10 squared plus 24 squared. So we get L squared as 100 plus, you have to square 24, which is 576. So L squared is 676, whoops, and L is 26, sorry, I got cut off. Now, some of you may have recognized this is a 5, 12, 13 multiplied by 2. If you didn't, that's okay. Either way, my L is 26. So I get 100 pi plus 260 pi. So a lot of times when they come out super clean like this, like my students like to leave it as 360 pi centimeters squared, which is about, if you wanted to do that, 1,130 point, we'll say 97 centimeters squared. So just real quick before we go on, if we have a prism, right, we have 2b plus LA. If we have a cylinder, we have 2 pi r squared plus 2 pi rh. In today's lesson, if we have a pyramid, it's 1b plus LA. And if we have a cone, it's pi r squared plus pi rl. You might want to just jot these down like on a little sticky note or a separate piece of paper. Like these are all the formulas you're going to need. Don't forget that your lateral area of prisms are going to be rectangles or parallelograms. Your lateral faces of your pyramids will be triangles. So naming the shape is like really critical to being good at these. All right, let's do at least one more. See what, oh yeah, I like these. Okay, so let's look at this guy right here, okay? So if they ask you to find the volume when we get to this of overlapping shapes, that's not going to be so bad because that's everything they hold, right? This one's tricky because we have basically it says find the surface area of the solid. The pyramids are regular. So that, but that tells you is this is a square pyramid and a square pyramid, okay? So they want to know the surface area. Well, the tricky part is, so basically you have square pyramid plus square pyramid, right? But you have overlapping going on here. These bases are overlapping each other. So if I was going to wrap this with something, I would not wrap the base. Now, I personally still like to write out big V plus LA, big V plus LA, and then just cross out whatever is overlapping. So those both bases would go away. So essentially, I just have to find the lateral faces, and actually they're all the same. So I just have to find 8 of these lateral faces here. So we've got 4 triangles here plus 4 triangles here. Okay, so what's the base of my triangle? It looks like that's pointing right there, so that's a 6. Now, are they giving me the height of the triangle? They are not. They're giving me this edge out here. So I have to cut that in half. So let's see. So I have to find this right here, the height of that triangle. So if I cut that out, let's see, this is 6. This whole thing would be 6, so this would be 3. And I need to find the height of that triangle. So this one, oops, man, sorry guys. You see that? This one would be 6 squared equals h squared plus 3 squared. So 36 is h squared plus 9. So 27 is h squared. I know that's 3 root 3 in my head, but we'll just get a decimal for this. Whoops. Second square root 27 is 5.2. So this height goes here, and then the exact same thing goes back here. So if you wanted to just do like 8 of these, you could have 6 times 5.2. Okay, the 4 times a half is going to make 2 times 6 times 5.2. So that's 62.4 plus, it's going to be the exact same thing back here. So this one ends up being 124.8 centimeters squared. All right, I think I'm going to stop there. So these aren't super long. Let me know if you have questions. You can obviously use your book. You can rewind these, kind of watch them again. And hopefully you're feeling good about this.